Hey guys, so we have started talking about continental drift and plate tectonics and how these giant plates move around our planet. And so the first boundary type that we're going to look at is going to be convergent boundary. So in your notebook, flip to page 8, and I need you to set it up like the picture, like the screen looks. Pause the video, definitely to do that. And so while we were filling this out, we were comparing the before and after. We were using a gizmo. So sketch that before picture. Remember, it doesn't have to be super perfect. And so looking at the gizmo, this is our before picture, and we're only going to focus on a small area, and so that was that red square on the last picture. But what I want you to do is watch what happens here, and draw that as your after picture in your notebook. Pause if you need to. So it looked something like this. Of course, I'm not perfect here, but that's the area we were looking at, that the two plates moved towards each other. So in this WH area up top, write down what happened. Describe either what happened in the picture, why you think it happened, what was formed. So in the what happened, you should have written something of mountains are formed, or that the two plates are moving towards each other and they push each other up, creating mountains. So in the bottom part of your paper, we have another side view of convergent boundary, continental to continental. And so as they move together, they create those mountaintops. And so the motion for this is collide. Remember, the C in convergent goes with the C in collide. They run into each other. As they run into each other, they move upwards. The feature, or like what's created on Earth from this type of boundary, is going to be a mountain. And the real world example are the Himalayan mountains, or Mount Everest. Every year that those mountains, they grow because those boundaries are still moving towards each other, and so each year they increase in height. So that's whenever you're looking at continental to continental, so it's the land running into each other. Another type of convergent boundary occurs whenever you have oceanic to continental and also oceanic to oceanic. So flip to page 9 and set up your page like this. Definitely pause the video. So same thing, we're going to look at the convergent boundary, but this time though we're looking at something called subduction. So this is whenever it's sinking below another plate. So draw that before picture. Same thing, put that square that I've drawn because we're going to focus on that area. On the gizmo, everyone's before picture looks the same. That's why I put that red box there. So we're looking at this type of boundary. Again, convergent boundary with subduction. And so same thing, we're going to click this, and I need you to sketch the after picture. And same thing, in this what happened, describe what happened. What was created, what did you observe, what changed. In the what happened, we should be saying something that a volcano was formed, that the plates moved towards each other, causing magma to come up to the surface. So we've got two instances when this can happen. It can either be whenever an oceanic plate meets a continental, or when an oceanic plate meets an oceanic plate. So starting off with this first one, or that middle section. Again, let's draw a picture. So we've got our continental plate running into our oceanic plate. Now, this oceanic plate, it's always going to sink below the continental because it's more dense. Over time, the water has pushed down a lot of sediments onto the bottom of the ocean and causing them to compact. It makes it a lot heavier. Plus, water is heavier than air. Another thing that's formed, oh, I forgot my water line. Another thing that's formed when these two plates meet, this area right here, that is a trench. And so remember, that's that large ditch that's there, a very deep area. So as that plate sinks below the other one, that plate melts back into the mantle, and it causes a lot of magma to collect. That magma is forced to move upwards. It has to leave, and so it moves up to the surface, creating a volcano. And so for this one too, the motion is going to be colliding. Any and every convergent boundary collide with each other. The feature is going to be a trench. That's that large ditch. And volcanic mountains. The real world example of this is going to be the Marianas Trench. And the Ring of Fire. So the Ring of Fire is it's a circular ring around the planet that it's around a boundary type that you have some of the most active volcanoes that are there. And then that other type of or other example of a convergent boundary is oceanic to oceanic. And so for this one too, you have a plate, you have another plate. So these are both going to be oceanic. However, the one that sinks below the other one, it has to be more dense, of course, because it sinks. But it's always going to be the older one because it has many more millions of years to add sediments to it, and so it's going to be heavier. Whereas this other one is going to be the young plate. So same thing, as that old plate subducts underneath the young one, magma builds and it's forced to the surface, resulting in volcanoes. Same thing, we have a trench. So the motion is the same, they collide, moves towards each other. The feature that is made from here is going to be an island arc, like an arc of islands, and a volcano. And then the real world examples of this are the Aleutian Islands, which can be found in Alaska. Also Japan. Japan is formed because over many, many years, that underwater volcano erupts and cools to where land builds up, and eventually that land breaches the surface of the water, and you have an island created.